Hey, what's up? How's it going, guys? I have another video for you today. Find the radius of convergence and the interval of convergence for the series. So you have summation starting at 1 going to infinity of 2x minus 1 to the n over 5 to the n root times square root n. So we do this like any other series. We first want to know what kind of, we want to find a to the n plus 1 over a to the n. Alright, so I'm going to do that right now. Everywhere we see n, we plug that in. So for the first one, we'll have 2x minus 1, this to the n, and then we'll have 2x minus 1 to the first, and then this is all over 5 to the n, and then 5 to the first, and then root n, which will just be root n, and then plus 1. I'm going to slide to the right a little bit, and then next part we have is just a to the n. So just write it as is basically, but flipped. If that's how you're used to doing it. So it'll be 2x minus 1 to the n, and then it's 5 to the n, and then root n. Alright. So now these are basically multiplying with this one right here. So let's look at what cancels. This 5 to the n will cancel, and then 2x minus 1 to the n and 2x minus 1 to the n, and then that means all we're left with is the 2x minus 1 to the first and the root n. So basically we can rewrite this as equals 2x minus 1 times root n over, you got 5 and square root n plus 1. Okay, so now we want to take the limit. We want to find the limit as n approaches infinity. So when you do that, you get 2x minus 1, and then you can factor out the root n. So you factor it from, let me move the equal sign, root n over root n, and then this is over square root of 1 plus 1 over root n. Alright, so now we apply the limit. Don't forget to add the 5, we still have a 5 there, and you're gonna get, this will go to 0, you'll just have 1, and then that basically means these two cancel, and you have 2x minus 1 over 5 is equal to 2x minus 1 over 5. Now that we have this, we want to basically set this equal to, let me move it. We have 2x minus 1 over 5, and then the bounds for it are 1 and negative 1. And then we just want to solve for x. So this is our radius of convergence, but we still have to solve for it. So multiply by 5, we have negative 5 less than or equal to 2x minus 1 less than or equal to 5. Add 1. Add 1 to both sides, you get negative 4 is less than or equal to 2x, it's less than or equal to 6. And then divide by 2, you get negative 2 is less than or equal to x is less than or equal to 3. So that means our radius of convergence now is 5. So the problem asks find the radius of convergence. You get 5. R is equal to 5. Now the interval of convergence is, it says negative 2 to 3, but we still have to test these endpoints. I'm going to test the endpoints now. So to test the endpoints, we just take the number and then we plug it back into what we had originally. So if we plug in negative 2 for x, we get